Hello and welcome back to another video of Amir's IB Guide. In today's video, we'll be looking at covalent polar bonds, uh, covalent non-polar bonds, and ionic bonding. This video is heavily credited towards the video with the same topic by the Organic Chem Tutor, so if you want to check him out, you're more than welcome to. And let's begin. So before we get into it, let's start with the basics. You should already know what a covalent bond is. A covalent bond is like when hydrogen with one outer shell bonds with another hydrogen with also has another hydrogen. They want to both achieve stability, so they share this electron. So hydrogen and hydrogen, they share it, and with two nonmetals, you have a bond where they share the electron. An ionic bond is when they transfer the electrons. For example, Na has one outer shell and Cl has 1, 2, 3, 4, 5, 6, and 7. In order to have a full outer shell, Na has to lose one and Cl needs to gain one. So Na will just give his little electron to Cl, and that way they will both be stable. But the important part in ionic is when Na loses the electron, so it becomes a cation, which is a positive ion. And since Cl loses it, Ca gains it, I mean, since Cl gains the negatively charged electron, it becomes an anion. Keep in mind, electrons are negatively charged. If someone gains it, they become uh, negative. If someone loses it, they become positive. So anion, which is negative. This is important. Okay. This is important because now we have Na positive and Cl negative. We know that positive forces attract each other, so there will be an electrostatic force between them, and force, and they will have a very good relationship with each other. This was important to know. Now that we're off to this, we'll start with polarity. Uh, An example of a nonpolar covalent bond is, again, hydrogen and hydrogen. And an example of a polar covalent bond is hydrogen and fluorine. So let's go with nonpolar and polar. Polar. This is very important to know, so keep this in mind. Here, in hydrogen, the share of electrons is equal because they're the same atoms bonding with each other. So the share of electrons is equal, the equal share of E's. And in a polar reaction bonding, which is a H and F, the share of electrons is not equal. What does equal and unequal mean? Well, this is where electronegativity comes in. Since they're the same atom and their share of electronegativity is the same, the bonding will be nonpolar. Let me explain it to you this way. So this will be 2.1, 2.1. This is their electronegativity value. Electronegativity is basically how much an atom wants the electron, how greedy they are for the electron, how bad they want it. Here, the difference between 2.1 and 2.1 is 0, so that means it's an equal bonding. Thus, it's nonpolar. If the electronegativity difference is a bit higher, then it becomes a polar bonding. So for example here, 2.1 again, but guess what? Fluorine is 4.0. 4.0 is too much, and that will create a polar bond. Why? Because think of it this way. Imagine you walk into a room and um, hydrogen is very generous and fluorine is very greedy. They're both sharing something. Maybe think of it as food. They're sharing a plate of food. You see that fluorine is being so greedy and eating everything, while hydrogen is being a bit more generous and says, come on, fluorine, let's just share it together and we'll eat it together, while fluorine is trying to eat more than him. Think of it this way. Now that you see those two, you'll say, okay, fluorine is greedier, so he is a negative person. Hydrogen is generous, so he's positive. That's why here we'll have H, hydrogen is what? Okay, hydrogen is partially positive and fluorine is partially negative. When the electronegativity of one of the atoms is very high, the electrons are going to spend more time with that one atom because it wants to attract them more. That's why hydrogen becomes more partially positive and fluorine becomes partially negative. And that's it. That's how you know that something is polar and something is nonpolar. This is very easy to understand because all you need to know is just the difference between their electronegativity. If they if the difference between their greed is too much, then they are polar. If it's not that much, it's nonpolar, or if it's none, if it's nonpolar, and if it's a lot, then it's ionic. So think of it this way: polar, um, no, let's say nonpolar first. Nonpolar, polar, and ionic. If the difference in electro electro stop doing that please. Electronegativity. Right now, if damn, why? Um, if the difference in electronegativity is less than zero point 0.4, such as the one we saw between hydrogen and hydrogen, it's nonpolar. If the difference in electronegativity is between zero point 0.5 till 1.9, such as the one we saw here, for example, fluorine and hydrogen, the difference was 1.9. So it's a very like cutting edge polar bond. It's 1.9, and if it's more than 1.9, it becomes an ionic bonding. An example of an ionic bonding, just the easiest way to spot an ionic bonding is when there is uh, a metal and when there is a non-metal. For example, we saw in the Na and Cl. The electronegativity of Na is Na electro Na electronegativity 0.93 and Cl is 3.16. So just imagine 3.16 minus as 0.93 is 2.23. So difference in electronegativity is 2.23. Looking at our table back here, you'll know that 2.23 counts as an ionic bond, and that's how you figure it out. That's it about what you need to know. Try to keep the concepts of greed and electronegativity is how greedy an atom is. In a molecule, if one of the atoms is greedier than the other, they will be partially negative because they spend more time with the electrons, and the one that's more generous is partially positive. And that's important because when there's polarity, there's this plus and minus thing that creates like electrostatic forces. And that's just very important because opposite forces attract each other. So keep that concept in mind. Know that you need to know that if it's less than zero point 0.4, it's nonpolar. If it's more and until 1.9, it's polar. And if it's more than that, it's ionic. Try to keep that in mind. And lastly, if there is an equal share, it's nonpolar. If it's not unequal, but it's not that much, it's polar. And if it's a huge difference in the inequality between the share of electrons, it's ionic. Thank you so much for watching. If you have any questions, comment it down below and subscribe. Thank you.